All right, so we just talked about some vocab and showed how we can graph these inequalities. Now let's do an example problem. So we got this little beautiful, cute little penguins here on the glacier. So example 1 says freezing point of water is 0 degrees Celsius. At temperatures at or below the freezing point, water is a solid, also known as ice. Write an inequality that gives the temperatures at which water is a solid, or when water is ice. Then graph the inequality. Let T represent the temperature of water. Water is a solid at temperatures less than or equal to 0 degrees Celsius. So that's what they said. The answer would just be T less than or equal to 0, because they did say that it would be ice at or below, so equal to or less than. And then here's the graph. We just have smaller numbers on the left, larger numbers on the right. You can do this. You could have done -1, -2, -3, and then 1, 2, 3, or -100, -200, -300. Doesn't really matter how you label your graph as long as it is consistent. And so we color in that dot there and then color everything to the left. Of course, if you guys have questions, find me on the Google Meet, hit me up on email. So solving inequalities. You can use the following properties to find solutions of inequalities involving addition or subtraction, or addition and subtraction. Using these properties, we can write equivalent inequalities. Equivalent inequalities are inequalities that have the same solution. So if you guys remember, our addition and properties of equality for equations said that if we subtracted one thing from one side of the equation, we had to subtract from the other side. And that if we did this on both sides by the same amount, that we would end up with an equivalent equation. It's the same idea here, same idea with inequalities. So maybe let me just give you an example. So if you guys remember, we would do x plus 3 equals 5. Now we're doing the same deal. It's x plus 3 greater than 5. We still use our material, so we have x plus 3 greater than 5. And we want to get rid of this 3, right? We want to cancel this positive 3 to get x by itself. And we know that we can cancel addition with subtraction or negatives. And when we have, and that this will cancel this out here. So 3 plus -3 is 0. And that cancels out over here. We did that on the other side as well. And then we end up with x is greater than 2. So really nothing has changed so far, other than the symbol in between the two expressions is an inequality opposed to an equation. Other than that, it's the same stuff we were doing before winter break. So here's another example. M plus 5 is greater than or equal to 10. So we have m plus 5 is greater than or equal to 10. We know that we can cancel positive 5 by subtracting 5 on both sides. We end up with 5 minus 5 is 0, so that cancels out. 10 minus 5 is 5, so we have m is greater than or equal to 5. And if we want to represent that as a graph, we just, again, have our number line. We have our dot right at 5. We have that colored in, and then all numbers greater than or equal to 5, that's why the dot's colored in, all numbers greater than 5 are colored in, because m could be any one of those. Before, remember, we could check our work by plugging in our solution back into the problem. We can do the same thing here. So we can just choose a number that's greater than or equal to 5. They chose 8. We could have chosen 6 or 7. That wouldn't have made a difference. So let's see. 8 plus 5 is 13. Is 13 greater than or equal to 10? Sure is. Right? So we know that. So that helps us feel a little more confident about our solution. All right, one more practice problem. We have -10 is greater than x minus 12. So actually, I'm going to stop here. I'm running out of time here. So I'm going to stop right here, and then we'll pick this up on the next video.